This is critical thinking on muscles. And here's the first question, which is a little general. And this one has a little bit more specific requirements. And here's another one similar to the second question, again, where you're a little specific, but you use principles of, you use the general principles. Now let's look at this one where it says you need to identify the incorrect statement. And the first statement is, a motor unit consists of an axon and the muscle fibers it innervates. Now this is a true statement because a motor unit does consist of an axon and the muscle fibers, the individual muscle fibers that it innervates. It may innervate 5 fibers, it may innervate 10 or even more. So that number doesn't matter. But all the fibers which are innervated by a single axon constitute one motor unit. So that is true. So it's important to remember that a motor unit consists of an axon and the muscle fibers it innervates, not the muscle. The second is, muscles crossing many joints or changing direction have greater range of action but less power. So the next statement, which talks about muscles crossing many joints or changing direction, have greater range of action but less power. Now this is also true. So if you look at a muscle, so let's say we have 3 bones and I'm just drawing them this way. A muscle which crosses one joint, which is just here, is going to be a short muscle, will act only on this joint. So hence it will be very powerful, but it's going to be able to move the joint only about this much because of its length. Let's say we have another muscle which crosses both the joints. So it's going to act on this one and this one. So it's going to have range because it's acting on 2 joints. Plus, because it's long, it's going to be able to move the joint a little bit more. So the movement will be more. But because its power is distributed across both joints, it becomes less powerful. So therefore, it is true. And this is also true for muscles which change direction. And one example is the extensor pollicis, which arises on the posterior aspect of the forearm from the ulna. So if we look at the ulna, so let's say that's the ulna, and then we have the posterior aspect of the radius. And this arises from the ulna and crosses, you can see it's changing its direction. It crosses the wrist posteriorly and then goes to the thumb. Now, as it does that, it will cause extension at the wrist joint, but because it's changing its direction, it's also capable of causing abduction of the thumb. And so hence you can see it, because of the change in direction, another range of motion is added to it, but it becomes less powerful. So therefore, this statement is also true. The third choice, which is isometric exercises, involve no movement at the joint, even though the muscle is contracting. This is also true because during isometric exercises, the muscle is contracting, the tension inside is increasing, but no joint movement occurs. And one extremely good example is that if you take your arm from the position from, when it's lying by the side of the body and you abduct it to 90 degrees. So you're abducting it to 90 degrees. So at this point, as deltoid acts and the muscle contracts and movement occurs, this is isotonic. Now you keep the muscle, you keep your arm stationary at the shoulder for some time over here. The muscle is still contracting, but no movement is occurring, but the tension inside the muscle increases, and so therefore this is isometric. And then after some time, let's say you bring the arm back down. So isometric exercises, that statement is true where it says no movement occurs even though the muscle is contracting. Let's look at the next statement, which says synergists are muscles which oppose the actions of the prime movers. This is false. Prime movers are the main muscles which perform action across a joint. For example, the brachialis causes flexion at the elbow joint. And biceps acts as a synergist. That means it is a helping muscle. Synergy is to help. So synergists are not antagonists. They don't oppose, they actually help the prime mover. So biceps is a synergist of the brachialis in performing flexion at the elbow joint. So this is the incorrect. So the answer would be this one, because this is the incorrect statement. And let's look at the last one. It says pronator teres is a muscle that is present in the forearm. Now muscles are named based on where they are located or their shape or different things or their actions. So if you look at this, pronator means it's a pronator. It will cause pronation. And if you think of it, pronation occurs in the forearm at the radio-ulnar joint. So it's very important to remember your skeletal system. So therefore, it will lie in the forearm because the radio-ulnar joints are present in the forearm. And teres, of course, means round. So this is a muscle that is present in the forearm, just as another muscle called pronator quadratus. So therefore, that is true. So the answer to this question would be number 4. Let's go to the next question, which is this one, which tells you that this muscle, flexor hallucis longus, arises from the posterior aspect of the fibula. So you're talking about the back of the leg. So let's say we are looking at this is the tibia, and let's say that's the fibula. And so it says it arises from the posterior aspect of the fibula. So it's arising from here. And it inserts into the plantar surface of the distal phalanx of the big toe. So it goes all the way, because it's hallucis, it has to go to the big toe. And the name also should tell you, it says flexor hallucis. That means it's a flexor of the toe. So here it goes all the way, and it tells you it goes to the distal phalanx of the big toe. Now if you look at the toes, in the bones in the toes, you have the metatarsal, and then you only have 2 phalanges. So you have only 2 phalanges, the proximal and the distal. Now this, so let's see what all it can do. Now since it's lying on the posterior aspect of the leg, so it crosses the ankle joint posteriorly, so it is not going to be able to cause dorsiflexion, because remember, dorsiflexion is done by muscles which cross anterior to the ankle. This is crossing posterior. The second question, a second statement, it causes flexion of the knee. Well, see, look here, the knee joint is above, and this is arising below the knee joint. So it's not going to have any action on the knee. You see, it says it arises from the fibula. It has to arise from the femur in order to act on the knee. So that too is, you can rule out that one. Now let's look at these statements. It says it causes plantar flexion of the ankle. So that is true. And flexion of the metatarsophalangeal joint of the big toe, which is this one. So that is true. But let's look at the next statement, which says causes plantar flexion of the ankle. Yes. Flexion of the metatarsophalangeal and interphalangeal joints of the big toe. Remember, this muscle, we said it goes to the distal phalanx. So it has to act also on the interphalangeal joint. So this statement is the one which takes care of all actions. Hence, this is the best answer for this. It's not that this is wrong, but this does not cover the interphalangeal joint. Hence, this is the correct answer. That's how you should be answering these kind of questions. Now, let's look at the next one, which is a little similar. And here it tells you that adductor brevis, so there is this adductor, it will cause adduction. Brevis means it's a small muscle. You have names such as Magnus or Maximus, which mean really big. Then you have names such as Brevis, or you'll have minor, that means these are smaller muscles. So this is adductor brevis, so it's an adductor, and then it will be a small muscle. Now let's see which joints it will act on. So it tells you it arises from the anterior aspect of the ischiopubic ramus. The ischiopubic ramus is part of the hip bone. So if you look at the hip bone up here, this is the muscle which arises from this ischiopubic ramus. And let's draw the acetabulum, and here is the femur. So let's say this is the femur here. So it tells you that it arises from the ischiopubic ramus, from the anterior aspect, and inserts on the upper part of the femur. So it goes to the upper part of the femur. So it goes here. So hence this muscle is only crossing the hip joint. So it will only act on the hip joint. So, these are little things that you should draw for yourself, and that will help you to answer the questions. So it says it is, you would conclude that it was a small muscle that would cause adduction at the knee joint. Now, obviously, this is false because you can see it goes to the femur. It does not cross the knee joint. So that is one. And secondly, knee joint only allows flexion and extension and a slight degree of rotation, which accompanies the flexion and extension. There is no adduction. So there itself, it should tell you that. Then it says it was a very large muscle that causes adduction at the hip joint. Now we said brevis means small, so it cannot be this one either. The third choice, it was a small muscle causing adduction at both hip and knee. It only causes adduction at hip, not knee. So this is also would not answer this. Here, the last one is the choice then. It says it is a small muscle because of the word brevis, causes adduction, adductor, at the hip joint, because you can see it arises from the ischiopubic ramus and goes to the upper part of the femur. It does not cross the knee joint. So hence, this is the right answer to this question.